share the screen now.
Sure.
Yeah, I think we stopped independent and dependent events. We started, but we went through very fast. We'll start there again. Dependent and dependent events. Two or more events are said to be independent when the outcome of one does not affect, is not affected by. C does not affect B, A does not affect B event. B does not affect A event. Then they are independent events. For example, coin is twice tossed. The result of that, just a second, I need to plug it in. I need to plug in my graphics tablet. We're trying to get vaccinated, but unfortunately, it's not happened.
Why, uncle?
Monday.
Oh, okay.
Today, my wife, I finished my vaccination, but my wife is not finished.
Okay.
Last time, what happened? She went and got vaccinated. Immediately, she got corona, just like daddy. So she's very afraid of getting vaccinated. So kept on postponing. Anyway, now that we are here, two or more independent events. Okay, A is one event. A is the event of tossing a coin. You will get head or tails. Okay. Then B is another event of tossing the same coin also. You will get head or tails. Now, if A you got head, doesn't depend on that whether you will get B tail or head. Okay. Nothing to do. That first event has nothing to do with the second event. That is only independent events. But not all the events are independent events. So far in 9th standard, 10th standard, we dealt only with the independent events. Now here you are going to deal with dependent events. Are those in which the occurrence or non-occurrence of one event in any one trial affects the other events in other trials. Okay. So one, for example, you draw a queen from a pack of 52 cards. That probability is 4 out of 52 because there will be 4 queens and there are 52 cards. So 4 out of 52 is the probability drawing queen from a pack. Okay. Now the card is not replaced in the pack. Okay. Then you are telling the second event D is the probability of drawing a queen from the same pack. Okay. Now there are only 51 cards. So total sample space S equal to 51. N is 51. And N of the possible events is now 3 because there are only 3 queens left. Okay. So the probabilities now become 3 by 51. Original probability was 4 by 52. So the first event is affecting the second event. This is the example of a dependent event. One event happens, it affects the occurrence of the next event or the other event. Okay, event A affects the occurrence of the event B. Okay. Now you got to express this in a algebraic set theory formula. How to express that? If two events A and B are dependent, then the conditional probability of B. Okay, why it is now become a conditional probability of B? Because B is now conditional upon what has happened at A. So event A has occurred, that is affecting the probability of event B. So event B is becoming 3 by 51 only because event A has occurred. So that is why it is called the conditional probability of B. Given that A has occurred already is P of B, given that A has occurred. Okay, this is P of B by A. Now, what is the meaning of P of B by A? The meaning of P of B by A is that the probability of B, given that A has occurred, okay, or conditional probability of B, given that A is, this is the meaning. So this has got lot of meaning when you write P of B by A. The probability, the conditional probability of B, given that A has occurred, is equal to P of A intersection B by P of A. That is the formula. Okay, you have to remember this formula. Same way, the other way around. Okay, first A occurs, then that affects how B occurs. You can also say B occurs, then that affects how A occurs. Now A is a condition here. So the conditional probability of A, given that B has occurred, is equal to P of A intersection B remains the same, divided by P of B. So remember, this will be at the bottom, this will be at the bottom all the time. A is at the bottom, then P of A is at the numerator, like that. Okay. And that event must have some probability of occurring. It should not be an impossible event. Impossible event, the formula does not hold because it becomes undefined. Okay. So P of B by A is P of A intersection B by P of A. P of A by B is equal to P of A intersection B by P of B. Okay, very simple thing to remember. Okay. Now let us go to the multiplication theorem. So we found that P of A intersection by A B by P of A is equal to P of B by A. What we found actually, this is nothing. No, we found that P of B given A is equal to P of A intersection B divided by P of A. You take this on the other side. So P of A intersection B now gets a different look. P of A intersection B equal to P of B given A into P of A. This is a multiplication theorem. Where the events are independent, what happens? If the events are independent, then P of B is not at all conditional upon A. So you have to remove that. P of B into P of A. So P of A intersection B is equal to P of B into P of A. In the same way, P of A intersection B intersection C is equal to P of A into P of B into P of C. This is for A, B, C are independent events. If they are dependent events, then this is the correct formula.
Okay.
So this is on the top, this is at the bottom. Yeah. So okay, this is what they are given. Independent events, P of A intersection B equal to P of A into P of B. And the same way, independent events, all three events are independent. P of A into P of B into P of C. Now let's do an example and try to see how these things work out in actual practice. Then only you can actually understand. Example 8.24 we'll do. An unbiased die is thrown. Okay. If A is the event of the number appearing, is a multiple of 3. So what is a multiple of 3? 3 will occur, 6 will occur. This is the sample set. Okay. A is outcome is 3 and outcome is 3. B is the event. Number appearing is even 2, 4, 6. B is that event. Okay. Now, then find whether A and B are independent. Okay. Now, how to find A and B are independent? The question. Now, 6 is occurring there, 6 is also occurring here. So, A intersection B is not a null set. Okay. A intersection B is equal to 6. And so, that is why sample space is 1, 2, 3, 4, 5, 6. A is 3, 6, B is 2, 4, 6, and A intersection B is 6. This and all we found out. Okay. Now, what you have to do, you have to apply the formula. A and B are independent means P of A intersection B will be equal to P of A into P of B. They are independent. Okay. So, we have to find out P of A, P of B, P of A intersection B, and then find out if they are left side is equal to right hand side. If left hand side is equal to right hand side, then they are independent. Okay. P of A intersection B is equal to 1 by 6. Okay, why? Because sample space number is 6. So this is the bottom is 6. But event number is only 1, n equal to only 1. Okay, so 1 by 6. Okay, P of A intersection B. Let us do P of A intersection B. 1 by 6. Now P of A, what is P of A? P of A is equal to 2 by 6. That is equal to 1/3. See, 2, there are 2, n is equal to 2 here. Okay. Then sample space again, whole size is equal to 6, n is equal to 6. So 2 by 6 equal to 1/3. Now let us find out what is P of B. P of B is again number of events, number of outcomes is 3, and total sample space is 3. That is equal to half. Okay. So P of A into P of B. How much is P of A into P of B? That is equal to this one into this one. 1/3 into half. That is equal to 1 by 6. Now we found out P of A intersection B is 1 by 6.
1 by 6.
So that is equal to P of A intersection B. Therefore, two events are independent. That's all. Huh?
Yeah.
So wait, one thing, I'll put this in your WhatsApp. Yeah. Example 8.25 will go now. This was very easy, you know. Find if they are independent events, just have to prove P of A intersection B equal to P of A into P of B. Again, he's asking if this find P of A intersection B if A and B are independent events. Okay, that means he is now telling that P of A intersection B is equal to P of A into P of B. So he's asking to find P of A intersection B is what? So you have to find P of A, you have to find P of B, then multiply the two. That's all. You'll get P intersection B. Okay. Because they are independent events. So P of A is 3 by 5. P of B is 1 by 5. So P of A intersection B is equal to this into that. Okay, 3 by 25. That's all. P of A intersection. This is a mental sum. 3 by 25. That's all. Nothing big deal about this. Now we are going to do example 8.26, which seems a real sum. Now it is real sum. Okay. These two sums are chumma, just for. Okay. Now you have to start thinking. 3 coins. Three coins are tossed simultaneously. Okay, you are having 3 people are standing, and immediately they are throwing the 3 coins up. Consider the event A, 3 heads or 3 tails. Okay, event A. So A is 3 heads or 3 tails. This is event A. Then B, at least 2 heads. So you have HHH, HHT, THH, then
HTH.
So this is probability is 4 by 8. Then that probability is only 2 by 8. and C is at most two heads. At most two heads means H won't come. So H, T, T, H, T, then less than two heads also you can have. So T, and then you can have H, T, C, also you can have. Okay, T, and T, also you can have. 1, 2, 3, 4, 5, 6, 7. So this is C event is equal to 7 by 8. Okay. Now, at most pairs of AB, AC, and BC, of the pairs AB, AC, and BC, which are independent, which are dependent. So what you have to do, for AB, you have to find A intersection B, and see if it is equal to P of A into P of B. LHS equal to RHS, you have to find. Okay, let us take it on the board. Let's take it on the board. That's quite a complex. So every time what you have to find, three combinations, event A and B. First you have to find if it is P of A into P of B. If it is yes, then they are independent. If it is no, then they are independent, like that. Same way you have to find for A intersection C. P of A into P of C you have to find. Okay, yes, they are equal, then independent. No, they are dependent. Same way, the third thing is telling P of B and C. P of B intersection. P of B into P of C. Same way, yes, no. Independent, dependent. Okay, this is how you have to prove the sum. This is the logic of the sum, what you have to do. What is P of A? Three coins are tossed simultaneously. Events A is equal to 3 heads or 3 tails. Okay. So P of A is 3 heads or 3 tails. We already saw HHH and TTT. So 2 by 8 is equal to 1/4 is equal to P of A. Now then find out P of B. P of B is 3 heads, at least 2 heads. Okay. So at least 2 heads, we had 1, 2, 3, 4. Was 4 by 8. Okay. So that is equal to 2 by 4 equal to half. This is P of B. Then P of C, at most 2 heads. That was 7 by 8. Okay. At most 2 heads was 7 by 8 P of C. Now do P of A intersection. P of A intersection C. Now you have to do P of A intersection C. P of A intersection C, we saw what is that between, okay, P of A, P of B was at least 2 heads. And P of C was everything other than that. Now P of A intersection B. This one and this one intersection. This is common. What else is common? Only one is common. That is P of A intersection B is equal to 1 by 8. Okay. Then let us do P of A intersection C. We'll try now. This two. HHH is not coming. TTT is not coming. So nothing is there. Huh? TTT is there. So TTT is there. Again, P of A intersection C is equal to TTT is there. Therefore, that also equal to 1 by 8. Then now P of B intersection C. P of B intersection C, what is there? HHT is there. Then HHT is there. HTH is there. THH is there. That's all. Okay, so that is equal to 3 by 8. Now what you have to do? Find P of A into P of C. First one. P of A intersection B. P of A into B. Now you have to find. P of A intersection B is 1 by 8. P of A into P of B is 1/4 into half. That is equal to 1 by 8. Therefore, A and B are independent. All right. Now you try. This is all LHS. This is all RHS. Now you try P of A intersection C is equal to 1 by 8 again. Whether now P of A into P of C, that is equal to P of A is
1 by 4.
1 by 4 into P of C is 7 by
7 by 8.
7 by 32. So 1 by 8 not equal to 7 by 32. So A and C are dependent. They are not independent. Then do P of B intersection C. P of B intersection C is 3 by 8. Now let us see P of B by P of C. P of B is how much? Half. P of C is 7 by 8. That is equal to 7 by 16. 7 by 16 not equal to 3 by 8. Therefore, B and C are dependent. Only A and B are independent. Okay, now I'll post this. Very simple sum, no? You got it. Okay. So look to big sums. So even A and B are independent. Even AC and BC are dependent. That's all. Now let's go to another problem. Example 8.27. Now A can solve 90% of the problems given in the book, and B can solve 70% of the problems. Okay. And that means what is the probability of A? P of A is equal to 0.9 and P of B is equal to 0.7. That is given. What is the probability that at least one of them will solve a problem selected at random? At least one of them will means either A or B, which means A of A union B you have to find out. You understand? A of A union B you have to find out. So probability A will be able to solve the problem is 9 by 10 we gave. B will be able to solve the problem 7 by 10. Already we found out. P of A 9 by 10, P of B 7 by 10. Okay. Now very interesting step he is taking, because you have only can find A intersection B in this formula. You can find only A intersection B in this method. So he is using another way. The probability that A cannot solve is 0.9. 1 minus 0.9 is 0.1. The probability that B cannot solve this thing. So those two important steps you should understand. These two are very important steps. That is what you have to use in your when you are solving the exercises also. So 1 minus 0.7 is equal to 0.3. So P at least one solve the problem. That's what we found. Okay, this one you have to remember. You have to understand. At least one of them can solve the problem. Means either A can solve it or B can solve it. Okay, that is the idea. You should not blink. What you have to find? At least one of them means A intersection B. No, A intersection B means the probability that both of them will solve the problem. That is only P of A intersection B. At least one of them will solve the problem means either one of them will solve the problem. That is A union B. Okay, either R is A union B. Both and is A intersection B. You know that, remember? So which one you translate into set language is very important. Otherwise, you will do everything wrong.
Okay.
Now, what is telling? At least one of them can solve the problem is P of A union B. This law you learnt in 10th standard. P of A union B is equal to 1 minus P of A union B the whole. Okay. See, very simple. Anything P of X is equal to 1 minus P of X dash. That's what he did here. P of A is equal to A dash equal to 1 minus P of A. Same way, P of A is equal to 1 minus P of A dash. Same way, P of A union B is equal to 1 minus P of A union B dash. Okay. Now only you are able to get the union is termed and classified and changed into an intersection issue. Only when you get an intersection issue, you can start applying the multiplication theorem. Okay. At least one of them is a union issue, A union B issue. But in this problem, you don't have, in your syllabus, you don't have any way to solve the A union B problem. You have only multiplication theorem. Multiplication theorem is only for A intersection B, correct?
Okay, yeah.
So somehow you have to change A union B into some intersection issue. Then only you can apply the multiplication theorem formula. Okay. Now these two events are independent events. One fellow solves the problem doesn't mean another fellow cannot solve. Okay. Both of them are breaking their head separately. Okay. Both of them are breaking their heads separately. So they are independent events. This fellow working in his home, the other fellow working in his own home. Okay. So they are independent events. இவன் பண்ணிட்டானா அவன் பண்ண முடியாது, இல்ல அவன் பண்ணிட்டானா இவன் பண்ண முடியாது. அந்த மாதிரி டிபெண்டன்சி எதுவுமே இல்ல. Okay, are you clear?
Yeah.
So they are independent events, so you can apply the multiplication theorem like this. You can apply the multiplication theorem. So P of A dash intersection P of B dash. Okay, this is all algebra from the 10th standard. So don't ask me how this has come. Go and see your 10th standard textbook. Okay, but we can prove it. We can prove it by Venn diagram. P of A union B the whole knot. This is A union B. P of A union B the whole knot will be everything else. Okay. Now P of A dash intersection B dash. A dash is nothing but all that is not A. B dash is nothing but all that is not B. What is the intersection of these two? only the outer one. Okay, same thing. So P of A union B the whole dash is equal to P of A dash intersection B dash. Okay, this is proved using Venn diagram. This is not your syllabus now. The Sunshine
Yeah,
syllabus. You should
I
know
know.
that.
I remember, uncle. Yeah.
Hmm.
They reduced this also. They put as a
It
reduced
came in your
also.
exercise. Okay. Now, once you got that, now you are having intersection, you can apply multiplication theorem. 1 minus P of A dash into P of B dash, you can apply now.
Hmm.
So P of A dash is what? 0.1, P of B dash is 0.3. So 1 minus 0.1 into 1 by 0.3 is equal to 0.03. 0.03. 1 minus 0.03. That is equal to 0.97. That's all. Let me put this also in here. You can still use it, right? Yeah, that's why.
Hmm.
Now let us go for example 8.28. This also very nice sum. A bag contains 5 white balls, 3 black balls, 1 bag. 2 balls are drawn at random, one after the another without replacement. Okay. Without replacement, independent event or dependent event. See that example I told you. First card is removed and it is not replaced. Okay. What does it become?
Independent, uncle.
No.
Without replacement, then it's
First card,
dependent.
first queen is got 4 by 52. But then you don't replace the queen. Next will become 3 by 51.
Okay.
Okay. If you replace it, it will again be 4 by 52. So event B is dependent on event A. So this is like this, P of B by A only. Without replacement, 5 white balls and 3 balls. They are balls are drawn at random, one after another. Okay. Let an A and B be the events of getting a black ball in the first and second draw. Both balls are black. Okay, both balls are black. That is what you have to find out. So black ball in the first draw is event A. Black ball in the second draw is event B.
Yeah.
So first attempt very easy to calculate. Drawing a black ball in the first attempt. There are 3 black balls. Total number of black balls. So n of the event by n of the total sample space. So 3 divided by 8. Total sample space 8 balls are there. How many black balls are there? 3 is there. So P of A is very easy. Now probability of drawing second black ball, given that the first ball is drawn is black. That means already 1 ball is gone. So how many balls are left? Only 2 black balls are left. Already one ball is taken away. So it is 2 by 7 only is the probability. So what you have to do now? P of B by A and P of A. They are not independent events. So P of A into P of B by A. So probability that both and means immediately intersection. Both balls. A is black. Both A is black and B is black. Both and means intersection. So they are asked to find the probability of intersection. So straightforward, you can apply the formula. P of A intersection B is equal to P of A into P of B given A. So 3 by 8 into 2 by 7, 6 by 56. 6 by 56 divided by 2, 3 by 28. That's all. You got the answer. Very important sum. First sum you are getting where the events are dependent. You have to find out dependency. P by A. or the conditional probability of B given A. So conditional probability of B given A is the one we should find out, and then P of A intersection B is multiplication law. You can apply it straight away. Okay. Yeah. Any issues? See, when the events were independent, how you applied? This one, example 8.27 was their independent event. So P of A dash intersection B dash, you directly said P of A dash into P of B dash. That's all. Directly you substituted this. Here you cannot do that. You have to do P of B divided by A. P of B given A. So that is one example that is over. Started at 11:30. Huh? We're going very slow, man. 40 minutes already. Okay. Example 8.29. Better to learn these examples very well. In a shooting test, the probability of hitting the target R for A, it is 3/4. For B, probability of B is equal to half, and probability of C is equal to 2/3. Okay. If all of them fire at the same target, calculate the probabilities that all that, see, these are independent events. Why they are independent? Because when A is not shooting B and killing him, okay, all of them are shooting independently at the target. That's all.
Yeah. Okay.
If see, it becomes dependent event. If once A shoots the target falls down. Then B does not have a target to shoot. Then it will become dependent event. So that those kind of things are not happening here. Okay, so it is all independent event. All three hit the target means P of A intersection B intersection C. Okay, both and same as all and. Both means come only if it is two events, it will come as both. If it is three or more events, it will come as all. Correct? Okay. Only one of them it's the target. That is very important. This is very important. Let us see how it is. Okay. At least one of them it's the target is A union B union C. Either one of them it's the target. Okay. Only one of them it's the target only is very important. Only one. How to find that out we will see here. Okay. Very important. Let us work this out separately. So we find all three hit the target A intersection B intersection C. Then we find this is the first one, example 8.29. First one. Third one also simple. At least one of them means A union B union C. Okay. Second one only is a problem. Only one of them hits it. Okay. So then data that is given P of A is equal to 3/4. First fellow hitting. P of B, second fellow hitting is half. Then P of C, third fellow hitting is 2/3. This is all given. Okay. So what you have to find again, I told you, whenever you have P of A union B union C, you cannot find that directly. You cannot find that directly. Okay. Okay. Now, first one you can find out P of A intersection B intersection C is equal to, they are independent events, P of A into P of B into P of C. Okay, very straightforward. 3/4 into half into 2/3. That is, this will go, this will go, this will go, this will go, 1/4. First answer. Okay, probability that all three will hit the same target is 1/4. Now, second one only problem. Only one of them, it's the target, is very, very complex. Okay. P of A intersection B naught and C naught. What is this meaning? A will hit the target. Okay. B will not hit the target. C will not hit the target. You understand? James,
Yeah.
very important.
Hmm.
Intersection. All three events occur. What three events occur? A will hit it. B will not hit and C will not hit. That is expressed how A intersection B dash and C dash. B naught and C naught. Okay, like that. Okay, that is only A. Then you have to have another one, union of P of A dash intersection B hits it, intersection C does not hit it. Union, okay, A does not hit it, B does not hit it, only C hits it. So this is only C hits it, this is only B hits it, this is only A hits it. Now what you have to do, either only A or either only B or only C, either, okay. When you have either, you have to put union, either or, okay. You understand? So this whole thing is you have to find out the probability. So very interesting problem, very interesting. Now what you have to find out, therefore you have to find out P of A naught, P of B naught, and P of C naught, C dash. All that you have to find out, otherwise you can't substitute and find. So P of A naught is equal to 1 minus P of A. Correct? P of A is how much? 3/4. That is equal to 1/4 P of A naught. Same way P of B naught is equal to 1 minus P of B. That is equal to 1 minus half. Is equal to half. That is equal to P of B naught or B dash. P of C dash equal to 1 minus P of C. That is equal to 1 minus 2/3. That is equal to 1/3. Okay, this is P of C dash. Now you substitute the values here. What you will get? P of A intersection B naught and C naught. P of, okay, this is all intersection. Okay, and they are independent events. So you can multiply P of A into P of B dash into P of C dash plus P of A dash into P of B into P of C dash plus P of A dash into P of B dash into P of C. Okay, how you got this? Multiplication theorem you are using. P of A intersection B intersection C, A intersection B dash intersection C dash. So you just multiply P of A into P of B dash into P of C dash because they are all independent events. Okay, you understand?
Yeah.
Independent events. So you apply multiplication theorem. So this plus this plus this. Why plus here? Because union. Why plus here?
Because of union.
Because of union. Okay. P of A is how much? 3/4. P of B dash is how much? Half. Here. P of B dash. P of C dash is how much? 1/3. 1/3. Plus P of A dash how much?
Uncle, P of C is 2/3, no, Uncle.
P of C dash you have to take.
No, Uncle. P of C you took, right? Instead of 2/3, you put 1/3.
First, P of C is 2/3. Okay. P of C is equal to 2/3. P of C dash is how much? 1 minus P of C. 1 minus 2/3. That is equal to 1/3. That is what you are having here. This one.
Understood, yeah.
So that 1/3 you are putting. Then P of A dash. 1 by 4th. 1/4 into P of B. B. What is P? P of B is half.
1 by 2.
P of B. Then P of C dash. Again 1/3.
1 by 3. Yeah.
Plus what do you have to do? P of A dash. P of A dash is here
1
1/4.
by 4. 1 by 4.
1/4. P of B dash again here half.
1 by 2.
Now P of C. P of C
2 by
is
3. 2 by
2 by
3.
3.
Yeah.
Now you calculate all this. 4 into 2 into 3. 3 I will go into 3. 1 by 8. Then 4 into 2, 8. 8 into 3, 24.
4.
Okay. 2 and 2 will go. 4 into 3, 1 by 12.
1 by 12.
Okay. Now you have to calculate this.
LCM.
That is equal to, take 24 as LCM. 1 plus 3 plus 2. 3, 4, 5, 6. That is equal to 6 by 24. 1 by 4. All right. So, second thing is 1 by 4. 2. Second one is 1 by 4. First one is 1 by 4. Now we have to find third one. Third one, P of A union B union C. So you don't have direct formula for finding A union B union C. Okay. So that we have to use the ulta. How to use the ulta? Wait, we will rub off some parts, then we can do it. At least one of them, it's the target. So at least one of them, it's the target is P of none of them, it's the target. Okay, none of them, it's the target. That equal to 1 minus B doesn't hit the target. B doesn't hit the target. C doesn't hit the target. Okay. So P of A union B union C. There also you found out previously. P of A union B will finally become 1 minus P of A intersection B intersection. Same way P of A union B will become 1 minus P of A intersection B intersection. Okay. Yeah. This is a formula you can easily apply. Previous problem you found P of A union B is equal to 1 minus P of A intersection B intersection. Okay, you found that out in giving the example 8.27. Same way like this, the extension. So 1 minus P of A dash into P of B dash into P of C dash. That's all. Very simple one. What is A dash?
A dash is 1 by 4.
1 by 4 into B dash.
B dash is 1 by 2.
And C, P of C dash.
1 by 3.
Very simple. 1 minus 4 into 2, 8. 8 into 3. 8 into 3.
24.
24. That is equal to 24 minus 1 by 24. At least one. All right. Now let us copy and paste this in your WhatsApp. Some very important. Huh? You understood the sum, no? Because if you don't understand why he is doing, simply they are giving the steps there. But why those steps is very important. Otherwise, you will only memorize and go and write it. What, James? You understood why we are doing every step, okay?
Yeah, uncle.
Okay, this second one. What is the meaning then? You tell me now. What is the meaning of this whole thing? Tell me now.
P only one of them hits the target.
Say that again.
P only one of them hits the target.
How it is that? Why it is so big?
Because they shoot it too many times.
No. Can you explain P of A intersection B dash intersection C dash, union A dash intersection B intersection C dash, union A dash intersection B dash intersection C. I want you to explain that in your own words. Please explain.
So A, B, C, all of them get one chance, uncle.
Okay.
Out of these three, only one will hit.
Only one is sitting.
Yeah. So A is like that, and then B dash and C dash didn't hit.
What does that mean? A and then intersection B dash intersection C dash. What does that mean?
They missed, uncle. They missed a shot.
A is hitting. B does not hit and C does not hit. That's what it means.
Yeah.
Then union next one. What does it mean?
Union A intersection B intersection C dash. So this time B hits the target.
A and C miss. They don't hit.
A and C will miss. Same way, union A dash intersection B dash intersection C. This time C hits the target.
So only C hits. A does not hit. B does not hit. Okay. Now, so only A hits, or only B hits, or only C hits. That is the final thing.
Yeah.
So you must be able to see this. What does this mean? Don't mug this. Only A hits, or only B,
or
only C hits. That is the meaning of this whole thing. If you don't understand the meaning, you will not be able to do that. And then you will get mistake. Okay. Don't mug it. Just remember it. That's all. So next step, you will understand why like that.
Yeah.
Because union means P of A union B is equal to P of A plus P of B. Okay, so they are taking. So P of A union B union C is equal to mutually exclusive events. Okay, P of A plus P of B plus P of C. That is why they are putting plus there.
Yeah. Understood.
Okay, let us go on with some very important. So we spent a lot of time there. Now again we are coming to dependent event. Dependent event. We'll do this problem. Find the probability of drawing a queen, a king, and a knave. Knave means jack, J. Okay. In that order, from a pack of cards in 3 consecutive draws, the card drawn not being replaced. So these are independent or dependent events?
The card not being replaced is dependent events.
Very good. Dependent events only. So you can't use P of A into P of B into P of C. You can't use that. Okay. You have to go for P of A, B divided by P by A. Okay, is equal to P of A intersection B divided by P of B. This is the formula you will have to use. Okay. First time, no problem. The card drawn is a queen. Second event, card drawn is a king. Third event, card drawn is a jack. Okay. A is not dependent on anything. So P of A very easy to find. But P of B is given A. And P of C is given A and B. All right. So 2 events it is dependent on. So first event, drawing a queen, very simple, 4 by 52. There will be 4 queens. Out of 52 cards, you can draw this thing very simple. Now, drawing a king card, given that the queen card has already been drawn. Okay. That means 1 card is gone. So how many remaining cards you are having? We're having remaining 51 cards. So that is become the sample space. But only queen is drawn, no? So all the 4 kings are remaining. So the probability of B given A has happened is 4 by 51. Not 3 by 51. If you draw another king, it become 3 by 51. But you're drawing a king, so 4 by 51. Probability of B given A. Now, see, probability of a knave means jack. Given that a queen and a king card have been drawn, 2 cards have been drawn. So how many is remaining cards? 50 cards are remaining. So this is the denominator. Now again, king and queen are drawn. 4 jacks will remain. That is 4 is there. 4 by 50. Okay. Probability of drawing a queen, a king, and knave in that order from a card of cards, the cards not being replaced. So very important. You got P of C given A and B is 4 by 50. So they are dependent events. The required probability of the compound event. What is the probability of the total event? P of A intersection B intersection C. C is given wrongly, useless for us. Probability of all 3 events occurring. Okay. P of A into, now you cannot put P of B, you have to put P of B by A. Then you have to put P of C given B and A. Okay. So we multiply 4 by 52 into 4 by 51 into 4 by 50. 4 into 4 into 4, 64. 50 into 52 into 51, 1,32,600. And once you put the calculation, 0.00048. Calculation and all I want to do there. You do it calculation. Understood?
Yeah.
This formula is very important.
Okay.
Usual formula for independent events is P of A intersection B intersection C is equal to P of A into P of B into P of C. Okay, but here they are dependent events. So P of A into P of B given A into P of C given A and B. Okay, that is how you have to do it. So that is done there of 1 hour over. Can we do Bayes' theorem next class then?
Yeah.
We do Bayes' theorem now. Bayes' theorem need some help. No need, no?
We can't, uncle. It's already 12:30. I have to cook also.
Okay. You have to go. Today you have school, huh?
No, uncle. Today I don't.